Hello everybody. Good morning, good afternoon, good night, wherever or whenever you are looking at this video. My name is Guillermo Chavez Ferrer. I'm the co-founder of BuSerDi, a digital service bureau based in Mexico. And I'm glad to be with you all to present to you an introduction to our new model, the new CURATOR DG series scanner, and an introduction to international best practices for document images, document image quality analysis, and determine if it's right or wrong, following international best practices. Even though there are three main practices that are being followed, the FADGI, the one that we're going to be focusing in, is the one proposed by the United States. Nonetheless, there's another one called Metamorphose, adopted mainly in the European community, and it comes from the Netherlands. And the ISO is the one that it's trying to unite all of these algorithms and metrics together, and nurturing from both of them. But in a sense, both of them are almost the same, and they do measure quality about the image. So with that said, I'm going to try to move into the presentation. Before I go into the presentation, I just like to explain that before we did a very, very long video, and this time we are cutting and we're trying to do a different approach. We'll do some exercises, and from the exercises, I believe you'll get a bit more of a sense of what the targets do and what do we mean by quality metrics, what are we measuring, instead of just saying we're just getting a 24-bit, 300 dpi or 600 dpi image that could be completely off the charts. So now let's move on to the presentation. I will be very brief and tell you along the way. So let me see if you can see right now the PowerPoint presentation. It should be there. This will try to help us move together. And again, happy holidays. Enjoy really the time that every single day that you live, enjoy it. And through these holidays, my best wishes for you, your family and friends. And at the same time, even though it's been very hard situation right now with all this pandemic, I do believe that these rough times can help us learn something. One thing that I try to learn or encourage is that maybe we understand now that a small seed can really populate all over the world. So let's try to put good seeds in, and maybe this small effort that we're doing down here to promote the cultural heritage and these best practices will influence others to follow and do a good pandemic, not a pandemic, but do a good extrapolation throughout the world and encourage people to use these metrics in all digitalization processes or document imaging processes. Okay, so as I put right here, the CURATOR scanner, the one that we're presenting, it was based, or it was mainly focused to apply and to meet those metrics established by the FADGI Association. We focus on 300 dpi, on 400 dpi right now, at 3-star levels. The level star is the tolerance they'll give you between 1, 2, 3, and 4 stars tolerances of quality. 4 stars being the best. We are not there. We'll keep on working, and every day we'll keep learning more. we'll keep working with you and we'll keep working every single day. So I don't know why it's not changing. Okay, there it goes. Okay, one of the main objectives of this presentation and to you all is to scan. How do you scan once so that you don't have to go back for the document, for the physical assets and the documents, and damage them again every time you touch the document, or you pass them because you want to, in the prep station, do lots of work. You are damaging more the work. So let's try to do it just once. And if you have planned and you understand the objectives that you need to meet, then by that it will be a great help of reducing reproduction work, because you just ask without really putting some goals and deliverables and what they have to meet. So let's do it the first time right. Now there's a small video that I have at the page. As a matter of fact, the scanner that you're looking at the top is the old Curator scanner, not this one. We'll update the page later on. And let's move into the agenda. As I was saying, it takes less time to do a thing right than it does to explain why you did it wrong. With that in mind, we'll go throughout the whole presentation and move on. Because I want to be very brief in the introduction of who we are and how we evolved to become scanner manufacturers. I will just give a very brief introduction, and later on we'll put a presentation of the BuSerDi evolution, and you can watch it in a later time. Also, on the ISO 19264 metamorphose and FADGI comparison, I won't go deeply into it, because on the exercises you'll be understanding what we are getting and how to work with it. I will put a link to a YouTube presentation that I saw that it's very, very good, and I think it will help if you want to get more into deep on the subject. Later on, we'll just move right on to the Curator DG scanner. And instead of me saying all the different features, I want you to be thinking of how you can use it. Not only think of this scanner that it's going to substitute everything. On the contrary, this is a complement to your institution, to your service bureau, to all those BPOs, because this is only for unbounded documents, unbounded papers. It will not reach the 4 stars, and maybe some documents that are extremely, extremely delicate, you may think of doing it in another way. But putting the documents through in maybe one single pass, then after analyzing those documents, you can determine which ones you want to pass them through a higher process. And it's something for you to keep in mind and see if that can work in your processes. So at the end, we have a point number 4, is how we see color. The objective of this point is to try to transmit to you that without objective and metrics, it will be almost impossible, if not it's impossible, to really determine if the quality of the image, and please be careful, I'm talking about the quality of the image, it's within the range that it was requested or not. Because if we rely on the BPO or in the project leader that is in charge of the project by its vision and their hardware only, most probably it will be a complete disaster, because that varies from day to day, and that's what we want to accomplish on that point. At the end, conclusions, well, actually, the conclusions, I prefer you make them yourselves from what you see, leaving comments, instead of me giving you the conclusions. And from there, keep working, and if you like this video, it will encourage us to do more videos that will focus in different aspects. Maybe the myths of actual throughput in the scanners, and different aspects. Let me move on. And let's go to the introduction. In here, just notice our web page for HEDS. It's heds.mx. You can also reach it by highenddocumentscanners.com, and BuSerDi is the BPO. As a brief introduction, this is a family business founded by my father in 1958 for doing photocopying, and it still stands, it's still working. And in 2001, BuSerDi was born, and we started building in-house changes and research of development for in-house modifications to great photomatrix, great scanners made by Photomatrix and ScanOptics that it was acquired later on by them. And now we this year started the division of high-end document scanners, even though we announced the first marathon scanner in 2018, that BuSerDi was the one doing all the work there. So now we have this division. Okay, so a brief introduction, as mentioned before. I won't go into the details of all the specs of the target test. This one, let me see. Okay, it's over here. But instead, by working in the examples, you'll acquire a taste for it and see the different means as problems arise in the live videos that we'll be doing. Also, I recommend I put there a web link from Digital Transitions. I don't personally know the company, but I've been in their content, in their YouTube content web page, and they have great material. And that link explains very well workflow or a process to control quality metrics within a production environment. One thing that I'm mentioning also here is we're focusing right now on the quality metrics. That doesn't mean that everything has passed. Maybe you have a double feed, you cut the image, you lost images or pages. That's another thing. But by using a target, at least one big problem is taken away. If you are within the limits, you pass. If you are out, you don't pass. So the quality of the image is something that it's already resolved by that. Getting a little bit more into FADGI. FADGI, the evolution, the way that I do, as I understand the evolution of FADGI, is a standard that started with libraries. And libraries, then it was adopted by museums, and museums, well, for example, museums started working together and trying to see why were so many differences in different web pages, and maybe see one image from Van Gogh in the museum page, completely different in the Met, or, well, not completely different, with variances in colors and things like that. So by falling into something that already existed, these metrics, now they can converge and be very close to each other and have a homogenized standard of metrics and quality to show and deliver to the rest of the world, so that we can appreciate those colors. Not only the colors are evaluated, also the focus, the sharpness, the noise that, and the different artifacts that we cannot just see it by eye, but we have to rely on some numbers in order to accept or reject the work that it's being asked for. So moving on from museums, we move to the archives. NARA has put a lot of work into metrics, standards, through many years. But one interesting point here that I consider it should be taken is that by 2022, there's a mandate, or I don't know if it's called a mandate, but there's an obligation or a goal to meet, that the National Archives of the U.S. won't be receiving any more physical assets, physical documents, and they will only receive digitized images. But the only way that they can be certain and feel certain that they are getting a true copy, or as close as a true copy as the original, and it has not been altered, it's by implying this metric, the FADGI standard. I still don't know exactly what are the goals there, the goals or the deviation they are going to allow, if they are going to be 1 star, 2, 3, or 4 stars. From what I heard, it's 3 stars, the thing that they'll be looking for. But it has to be evaluated by the federal agency of the same assets that they have, and from there move on. But the most important part of this is the example. They saw the need of how do I know that you haven't altered my images? Well, give me those numbers and then I know how much altered they are. If you just go for enhanced images, in enhanced imaging, the biggest problem is that it's an altered image. It's enhancing the image for different purposes. I'm not against enhancing images. We do have algorithms that gives you very beautiful pages, but those pages are with cut colors, with the speckle, with many different algorithms that were meant for other purposes. So one thing that I want to leave at the end is to leave you to always have a master image, or an image that you can rely on to later on reproduce new derivative images, because you don't know all the needs or why are they going to be used in the future, maybe for legal reasons, or maybe it's a historian, and the different actors have different views. So this should be adopted also not only for all government, as I mentioned before in the use that now they're taking it for all federal agencies, but it could also be taken by all industries. Industries that rely on quality, or aeronautical, financial, banks, insurance companies. We want to be as close as possible as the physical asset is. And then point number 4, I won't go into it because I will leave it at the end. The only thing that I want to take about these slides is recommend the different links that I'm putting here. There was a training course on color management that I took from LinkedIn. It's by Joe Brady. I will just be putting a clip, a 2-minute clip, because he explains much better than me the subjective and objective metrics and the need to use targets and calibration in order to be able to qualify or to give an okay to a quality image. The other link that I have there is one from the Monsell webpage that it's interesting if you do an exercise with all of your co-workers and do a simple test, and you'll see that test, the link will take you to a test to see how you see color, and you'll be amazed of how different maybe your colleagues see the different colors by taking that test. And now, with no further ado, we'll move in this 30-minute presentation of the scanner. And those are exercises using the test target. And I hope you do enjoy it. And let me move out now from this presentation and say goodbye. Adiós, cuídense, and enjoy yourselves. let's begin the actual presentation. HEDS, High-End Document Scanners. The manufacturing division at BuSerDi is very happy to bring to you the upgrader CURATOR DG series scanner, where the DG stands for Digital Guidelines. The intended audience is not just the cultural heritage community, but all of you facing any digitizing project for any type of collections or assets you may have in any industry or government agency, also including archives and different things. I hope to transmit to you all this distinct approach to digitize unbounded documents in a high-speed production environment, focusing to meet the FADGI 3 stars quality metrics. And for all of that, and for all of you that are not familiar with them, it will be a good introduction. So I will try not to go very into the details or technical details. I'll try to go over it, but by looking at it, I think it's going to be very helpful and hopefully understandable. Please do bear with me my English. I do have to practice it a little bit more, and many times I struggle to get the words out. So with that said, let's begin. First of all, I want to show you, this is a DICE target. This is a device level target. And being a device level, what it really measures is the capabilities of the system. The system being, for me, this scanner, but it's not limited only to that. It could measure a camera, even a phone. You take a picture of this image that it's already pre-measured and has different components and elements that will determine how far away or close to the actual metrics you are. So this is not based on the scanner, this is based on a lab target that we'll be using. So with no further ado, let's start scanning and see what comes out, and from there we'll start learning a little bit about this target test and the different components and elements around them. Okay, thank you. So let me try to change cameras now or to begin scanning. Okay, here I'll be using for this presentation, well, as you can see, this is a small computer. This is a Surface computer, so all processing is going to be done by the unit itself, and we'll be using the developer's program, so don't be afraid of the user interface. We do have another program with a more suitable or friendly user interface. This is not so bad, but I will show it to you too. So right now I'm going to scan just TIFF images, and let me just change the screen so that you can see what I'm talking about. Okay, let me put here and change it over here. Okay, I think now you can see my screen and also the scanner. So in here in the screen, in my desktop, I have this program that I'm going to tell it to scan color TIFF images. These are uncompressed, lossless images, and I will prepare the scanner. Well, while preparing the scanner, it's good to mention that we have two modes of scanning. I'm just getting a piece of paper right now so that you can see, just by pressing a button, this button, I will press it again and throw in a document, and as you see, the page flipped. Normally when you are in constant use, you have this board on top and all pages will be turning around. If you have more delicate documents, you can take it off and let them pass through. And in the same batch, if I press it again, then I go in a complete straight path through, so I don't damage the paper. I like to take care of this document because it's expensive paper. It's an expensive lab test target, but I want to use it very frequently. So that's why I placed it on this cardboard. Well, it's mainly plastic, so that I can protect the target and do many tests with it. And maybe in a production environment, I could be putting it in many times, like every box or every shift or every week. That depends on your workflow, or if you want it every book, you can also be putting it in. So with that said, I'm gonna pass again the image, and let's see what it came out. I'm going to change now so that you see the desktop. I will pause the scanner. I stop it so that there's no the noise. And as you can see, I just generated this batch. This is at 1302, and right now it's 1304. So these are the images I just took. Correct? So that's just showing in the Finder. And what I'm going to do right now is open my Golden Thread program. This is a third-party software that evaluates and gets the results, gets the metrics and all the components of the acquired image. There's also, I believe, a DICE free software delivered by the Library of Congress. Nonetheless, I love this program because it has many features that can really help you determine where your faults are and how to manage them. I see it as a doctor. So when you know the problem, then you can know how to solve it. So here we're going to be evaluating at 400 dpi. sRGB is the color space, and looking for the 3 stars. So coming over here, I'm going to get these 2 images and select them. Now the software is doing the job of processing them. And now let's see the results. Here, what it's being evaluated, it's different. I know that many people, this is supposed to be an introduction. So what we're evaluating is the tone scale, the white balance, uniformity, sampling frequency and efficiency, noise, and for those things, let's come and see where we are. Actually, this is a very good result. Hence, I don't know if you can see in the screen when I turn this show gamma or not. That's my aiming curve of the tonal range that I'm looking at. On the left hand side, we have all my highlights. My darks are on the back, and the mid-tones are over here. Normally in cultural heritage and documents, the most important parts are in the mid-tones. Nonetheless, it's best to have all the tonal range and keep do not clip the highlights or the background, even though they will deliver a very beautiful, nice image with high contrast, but that could be a derivative image, not the master image that we're looking for, and especially for having a true copy of the original. We do not want to alter those documents. So here is the main results that we got. Oh, I see the noise is a little bit up, but even though it's up, it passes because we have a tolerance of 10. We can post-process, or at the same time process the documents by implementing an ICC color profile. If I come over here and let's see, in Golden Thread, in my settings, I come and I'm going to open a color profile. The color profiles, they are always made per camera. Like this scanner has 2 cameras, so one is for the top camera and one is for the bottom camera. So with this profile, if I were to evaluate these same images again and let the Golden Thread software do the work, we can see that the points of the regions of interest are evaluated, and it's passed. But coming back to the color part, you see that now we are just below, by putting the ICC profile, we are below 4. So that's great. That's even a good result, I believe, even for 4 stars, even though we are not aiming for that. Many of the different parameters that are shown here are passed, and these are very good images. In the next test that I want to show you, I want to focus on getting 2 images. Normally, in many RFPs that I see many mistakes that people want to have very compressed images because they're doing a lot of images and they don't want to, and they want a lot of compression but retain 100% quality, something that I believe is impossible because there's a balance, and you pay, if you want more compression, you are going to get less something you're going to pay for, maybe on sharpness or noise or anything like that. Right now with these systems we can scan at the same time different outputs. So in here I could put, give me a JPEG color image, the color TIFF image, or even a JPEG2000 image. I'll put the 3 of them, even though I won't evaluate the JPEG2000 image, hence the decoder of Golden Thread as it is right now, or the version that I have right now, does not decode the JPEG 2000 images I am producing. Let me change so that you can see also the scanning part. This could be, let me put it here. So you'll see what I'm doing right now and how simple and how delicate the transport is, even though it's going at 32 inches per second. That will give me an output throughput of the scanner all the way up to 180 pages, but the design of this system is to be manual fed. So please forget about those 180 pages, and the velocity or the throughput is going to be determined by the users and the media or the paper that you are putting through. Normally in a constant use, operators can go like 60 pages per minute, 40 pages per minute. And if they are in a rush, because some of my operators sometimes do competitions, they can even reach 110 pages. But actually they won't be able to sustain that speed for more than 5 minutes. So consider when you are doing that even though this has the capability of going at 180 pages, there is no human way to pass all those documents through. So with that said, I'm going to put again the desktop, and let's see what we came out with. Again, I'm coming here to the Golden Thread, and let's pick up those images. I go one, there's a new batch that we just created where I was just putting these images. And as you can see, you see many images because I have the JPEG, the TIFF, and the JPEG 2000. At the same time, 3 images came out. So let me just to show you right now, because this is something that we'll be talking in a while. My uncompressed image, the TIFF image, measures 40 megs, where my JPEG image, right now I have the JPEG set up at 100% quality. This is the best quality JPEG possible, and it's only 3 megs. The JPEG 2000 that unfortunately I won't be able to show you, because as I mentioned before, it's not being decoded correctly right now in Golden Thread. Some other programs like Photoshop, Affinity Photo, or other programs do open them correctly, and maybe this is something interesting for people from my IIIS to test them, if Mirador or the different versions of the software could open these JPEG 2000 images, or if we have to work on them. Okay, so what I'll do here is I'll select all images and exclude the JPEG2000 ones. And here's another one. So I have 1, 2, 3, and 4 scans, and I will tell Golden Thread to evaluate both the TIFF image and the JPEG image. While that is being processed, we can discuss a little bit on we can discuss maybe a bit more on the actual things that Golden Thread is doing, like tone scale. It's do you have the tonal range, the complete tonal range from the whites to the blacks? That range is going to give us a lot of information. Color, when we're measuring color, how deviated we are. As I will put in another video, all of us see the color differently. Mainly, but like, there was an article I read that a woman, 1 in every 8, no, well, I'm not quite sure right now, but at the end, women do see better than men. It's easier for men to have color deficiencies, so to evaluate just by looking at the images, you won't really know what you are really getting or what you are archiving or preserving as a record. So that's why it's very important to have numbers and metrics so that you know those deviations and where they are. Okay, with that said, let's change again and let's see the results. As you can see the results with a JPEG image and a TIFF, both passes and all the images did pass through. If I come here and look at, let's say, my noise, I see a little bump here, maybe it's at patch somewhere around 18 or something like that, but we're well below the limit of 4 for each of the 3 channels, the red, green, and blue channels that are being evaluated. Our resolution, that's something that we were talking about, and it's very interesting. It's 400 dpi. This is my sampling frequency. The sampling, that it's normally what the RFPs are, or when you open your Explorer, you'll see in properties that it's 400 dpi. But that 400 dpi doesn't really determine if it's a good quality image or not. It just is telling you that there's 400 points in 1 inch. Maybe you are completely out of focus, or maybe your lens has a lot of dust, and many things can influence, or there's a lot of compression. That's the next example that I'm going to do. There's a lot of compression, and then your efficiency or your effective DPI is the ones that degenerate, and the 400 will stay, but this will come down, and we'll see it in just a few minutes. My color is very good as before, the tone scale, and if I go back, this was my TIFF image, the one that I was showing all the details. When I compare it, that same image number 4, but with the format of a JPEG, my JPEG output, I still have a little bit of more noise, but it's still within the range. So I have 396, it came out a little bit the DPI, but I'm in range, so that's why it passes. And they did pass as master images. So if you have a big project that you are going to do a transformation of, let's say, more than 100,000 images or 10,000 boxes of pages, and your concern is that you don't want to, let me show you here again, images, I'll go back, and you don't want, if I move here to details, how do I see the details? View, details, and you don't want to store 40 megs, you can store 3 megs. But the only thing that you have to be careful if you want to treat the JPEG images as master images is that please never save them again. You can duplicate them, and from there generate derivative images, because once you have a loosely image, save many times, you are losing bits, and every time it gets saved randomly within a certain period of times, so you'll be losing the quality. So that's why it is recommended to keep those JPEG images as master images, and from there generate duplicates and have distinct derivatives, maybe for high compression, OCR, and different types of post-processing or pre-processing or processing that you can do. Fortunately, on this system, we can output at the same time master images and enhance images. I'll say the word enhance. I don't like it that much, because truly we're not really enhancing the images. We are putting them for a final purpose, to make them look beautiful, to make them weight less, and things like that. So with that said, let's go to the next test that I want to show you. In here, what I'll do is show you a little bit what happens if I were to change my JPEG quality. Instead of having 100% quality, let's say I change to 10%. That means I have 90% quality and 10% reduction. Let me save this, and then I'll move to 20%, so you can see really how does it behave when we ask that we need maybe 300K images at 400 dpi, or things like that. So with that said, let's put here, I'll stop the grabber program. Even I will exit it, because I want the ini file to be read. Here you can see the images, and again I will take out the JPEG2000 images and start scanning. Just by the noise, I'm not changing now the windows, but you'll hear when I pass the pages. So now I put 3 pages in, stop the scanner, move to golden thread again. Let's go up 1, and now this is the new batch that I just generated. Get these images. Since I don't have the JPEG2000, now I feel free to put them out. Now I select them, and let's see what happens. I've already seen something that failed. Most probably is going to be the JPEG image. That's why because instead of having 100% quality, now I have 90% quality. The number that I put is the amount of compression that I could go all the way to 100. And actually, after 80% is an exponential curve, so you get less benefit and more damage to images after 20% of compression. So at the most I would go to 20%, but not for master images, and I'll show you why. In just 1 second, let's see if those images did pass. Okay, so my TIFF image passed, but the same TIFF image, and I'll see the resolution. I'm above, the effective DPI is above 400. And this is my sampling frequency up here, vertical and horizontal, 400. Now, when I go back and get that same image that was processed in the scanner from the raw image and compress within the scanner so that we have this output, now, as you can see, my effective DPI did change to 352. 353, and that was just with 90% quality. So, and actually my sampling, the one that normally gives me the okay on my jobs, it's still 400 dpi, but as I go down, those results will come much lower. Let me show you just in a way to read the targets. If I were to open these images again, oh, sorry. See, I'll open first the JPEG image. Let me come down a bit. And just by zooming in here, you can see the focus and how I am losing at before 400 dpi that I was supposed to scan. Now my lines start to get together. I'm going to try to leave this image open and at the same time open the TIFF image. Of course, this is the 40 megs image, but if we compare them side by side, you can see the white spaces here between the black lines, so this is above 400. And in here, there's a lot of artifacts that come into the image. Let me show you even the image that we did before, the one that had the 100% quality of the JPEG images. I'll open the first one and compare both JPEGs with 10% compression and the quality of one without compression. This is just a 3 meg image. Hopefully you can see the differences. In my computer I do see them, but this is a video and I'm transmitting, so I don't know if this is can be shown. Let me just go. This is the one with no compression being 3 megs, and this is with 10% compression, and you can see now the differences here. See? We could even go 20 and 10, and this 10%, how much storage did it represent? Instead of having this 3 megs, let's go back again and go to my last batch and see the details. Now I have 1 meg of a 400 dpi image, fully put. I could go to 80%, and after 80% it will be like 800K, but I wouldn't go further. So this is just the testing. When I put, obviously you saw the ICC calibration. Maybe I'll do a video later on putting the color checker SG and show you how we do ICC calibration on the scanner too. And let me just change the camera. I don't want to go too long. This is the first video we're doing. And 1 second, please. Okay, again, back again here. So this was just the first sample and a first introduction to the FADGI test target, working in conjunction with the Curator scanners that we're building here. We are very happy and we put a lot of work into it. I am very thankful for the people from BAP or BAPIS. This is a German-American company that helped us a lot throughout the development and the achievement of this unit and these metrics. And I think there's a great opportunity for all those universities, libraries, librarians, archives, and especially the federal government. I believe now they have a commitment for 2022 where all federal agencies must, by 2022, will digitize the paper because the National Archives won't be receiving the physical documents. And hence they won't be receiving physical documents. They want to know that they are receiving a true copy or as much as a true copy of the original. So these best practices that were acquired maybe from librarians, passed to museums and archives and federal agencies, I think are the new way for industries that have ISO quality metrics, aeronautical or many industry, legal, insurance, banking, financial, to really have a true copy of the original. Once you edit those originals, then you are not certain of what you're getting. I'm on favor also of the enhanced images for different purposes, as mentioned before. If I really need to low bandwidth and I need just to send information because I'm an accountant, then from my master image I can deliver other images, even black and white images, or have high contrasting images for different purposes, and I don't want to see all the stains in the documents. But maybe a historian is the one that is going to be very happy of looking at those stains and saying, oh, from here I can get more information that I couldn't get before because it was clipped. Even in a legal debate, it's best to have all the information backing up than to have algorithms that maybe remove some dots, like the dispeckle, and at the end you are not certain if maybe a comma was removed too. I'm maybe exaggerating, but it has happened and many times, especially when you have thermal paper and it's very light, the images, and you are clipping, you are going to lose more information, and maybe a voucher you cannot negotiate or a signature. You won't have all the elements to prove that they are there. The derivative images could be passing around and do collaboration, and the master images maybe can help you for disaster recovery plans. So hopefully I didn't go too long. Before I was doing another type of video with a PowerPoint presentation, but it came out very, very long. So I preferred to come directly to the scanner, give this introduction, and if you like it, please do subscribe to the new channel of HEDS, High-End Document Scanners, because it's a new channel in YouTube, and from what I read, I need to acquire so many hours in order to do live streaming via YouTube. I'm also putting this in LinkedIn, and I will also, with my people, work together on trying to figure out these new ways of marketing, because I'm not so familiar with it. Hope you liked it, and if you liked it, I'm going to put links and different references of the institutions that work, the FADGI, Metamorphose, the ISO standard, if you want to get a little bit more in depth into quality metrics. So that's digitizing unbounded books, and I hope you liked it.